Hi, I'm Billy, and this is Knox Machining. Welcome to the shop.
Hi, welcome back. So a while ago, I was participating in Harold Waters' ARW Sunday discussion, and we were talking about our experience and past projects. I happened to mention that I had converted and built several CNC machines and was rather versed in the subject. Mark, with Winky's Woorkshop, reached out to me and was curious if I could help him with a conversion. He wanted to convert his DIY wood lathe to CNC. So we're doing a collaborative project. I'm working on the electronics and the software, and Mark's going to work on the mechanical. So let's take a look and see what we've done. Okay, so here we have the enclosure for the electronics. Let's go over a couple things. Here we have the 48 volt 7 amp power supply for the stepper motors. Here we have the stepper drivers for the Z and the X axis. Up here we have the 7996 MESA interface card. This card generates the step and direction signals for the stepper drivers, and it also handles the input and output for limit switches and the e-stop and any other accessories we want to add. Down here we have the power distribution blocks. On this side here we have the DC side. We'll have 48 volts on these and 5 volts on these. This here is a 5 volt power supply to power the MESA card, and over here we have the AC terminals. Also have a power switch and an indicator lamp down here. Along with all that, we've got some wire loom to keep everything nice and tidy. I'm going to pull this board out, and we're going to do a time lapse of me wiring it up. Okay, so before I start terminating these wires, I want to talk about this for just a minute. Most beginners start off by using, when they do the wire, they'll tin the wire with solder, or they'll just crimp the wire or use the wire bare in these little terminal blocks. The best way to do this, though, is to use these little things here. Let's see if you can get that to focus. There you go. They're called ferrules, and use a crimper like this to crimp them, and it provides a much better connection. I've switched to those and never looked back. Okay, so we're back from the time lapse. It's been a few days now. I went through and labeled all the wiring with some heat shrink tubing that has the labels printed on it. In addition to that, I went ahead and printed up a label with the MESA breakout board on it, indicating all the different connections for him. Here we have a stepper motor. Both stepper motors have these covers that were 3D printed and installed, along with the connector. I made up the cables for him, so each one of them is also labeled. So there's the one for the Z-axis, one for the X-axis, and one for the I/O also. In addition to that, we have this little breakout DIN rail. This will mount in a small enclosure on the back of the lathe itself. Each one of these little flags represents a switch that he's going to connect up. So he'll pull the jumper off and install the switch on these two terminals for the X home. There's one for the Z home, there's one for the Z limit, and there's one for the emergency stop. All right. And lastly, we have a Beelink little computer here. We have LinuxCNC installed on that. I'll add some video clips of the installation. Lastly, I need to print up another label down here for the connectors on the, or for the DIN connectors, so that he's got that documented as well. And I'll be shipping this off to him pretty shortly. Next video you will see regarding this will be him installing it. Okay, so we have the Beelink computer booting up with LinuxCNC already installed. Okay, we're up. So let me go ahead and toggle the machine on. That's the enable button right there. I'm going to load a sample file. This is a chess piece for a pawn. It comes default with LinuxCNC. I'm just going to zoom in here so you can see it a little better. Now I'm going to home the axis. I've got an external switch here I'm using for this, since this is all, you know, set up to be simulations. Home all. All right, it's searching for the home switch. It tripped it, and now it's latching, and it's driving to its home position. I'll talk about that a little bit later. Now let's run a test program here. I hit the run button. I did modify this program a little bit. First thing you're going to see is it's going to be doing some facing cuts. The modification I made was to speed it up for the camera, so it's running a little faster than it normally would. The white lines are the cut lines that it's going to be doing. The teal lines are the rapids. And the pink lines are the path that it's already taken. You can see right now it's doing roughing cuts to get the general shape of the pawn cut down, turned down, I should say. It will do a little bit of profiling here. You'll also see that there's a secondary profile there, and that's the final profile it's going to do. More roughing passes. All right, now it's getting ready to do the final finish pass. Okay, and it's now done. So that was LinuxCNC in action there. I'm going to go ahead and exit out. I'll show you the configuration. Come up here to CNC. You've got two options. You've got PNC Comp Wizard and Step Comp Wizard. The difference is the interfaces. Step Comp uses the parallel port with a traditional breakout board. PNC Comp Wizard uses MESA cards, which is what we're using in this machine. And I would recommend that you use those actually. Open up an existing configuration that we've already done for the Wood CNC. This first screen here is the basic information. You got the Wood CNC as the name of the machine, and axis configuration. This describes the machine type. In this case, it's a lathe, so it's an X and Z axis. You can do a traditional mill, or you can do something with an A axis additional. Some timing information that we're not going to worry with, and you can specify additional controllers, like if you had more than one MESA card, or if you're also using parallel ports also. and some other stuff that we're just not going to be concerned about with right now. All right, this screen here describes the interface that you're going to be using, the GUI. You've got an option of choosing a couple different ones. We're going to stick with Axis, which is the predominant GUI for LinuxCNC. Over here you have some override information for the spindle, the minimum and maximum. This machine does not control the spindle, so those are irrelevant for our application. But we do have a feed override here of 200%, and I think 200% is the maximum you can put in there. Over here is the information for the linear velocity. Default's 15, minimum is half an inch per minute, and max is 70 inches a minute. Over here is for angular velocity. That would be like if you're running an A-axis or some other type of axis. We're not, so that's irrelevant to our needs, so we didn't even mess with that. I'm going to move on to the next screen here, virtual control panel. This is set up so that you can add additional controls and display information. We're not doing any of that for this configuration, so we're just going to move on through. Now we get into the MESA configuration. We are using a MESA 7996 as indicated here in the firmware. This is the IP address of the card. That's what it is defaulted. We did not make any changes on that, and all the rest of this is standard information as well, default information. And click on the TB3 tab here. This tab corresponds to the input-output connectors on the board. In the 0 spot here we have the input for the E-stop. In number 1 here we have the one for the Z minimum limit. And in the number 2 we have this input for the home switches, and they're in series. And these are normally closed, so in order for it to work correctly, we had to invert the input on that, and that's why these two little check boxes have been checked. Next tab here we have this TB1/TB2 tab. This is for the stepper motors. In 0 here we have the X-axis, and in 1 we have the Z-axis, and we have the direction and the step. And you'll notice that in both of these we have the direction pins inverted as well. That's so that the stepper motor rotates in the correct direction based on its orientation and lead screw. You have left-handed and right-handed threads. Both, in this case, both lead screws are right-handed, but a lot of machines, some of them will be left-handed, so you can change it up if you need to. P1 is not being used in this configuration. All right, now it says X motor, and this is to describe information about the driver for the X-axis motor. We're using 5056D stepper drivers, and I'll link to those down below. But the Kelling 4030 driver type specified here, basically just these timings here, and those work fine for those drivers, so that's what we're using. Down here we have a calculate scale, and click on that, and it's a little wizard. You can put in your pulley teeth and your worm ratios if you're using that, but in this configuration it's a direct drive, so we don't have any of that. We are using micro stepping, so we're using 8 as the factor, so I've got that plugged in there. And you can specify the metric pitch or the threads per inch, depending on whether you're using metric screws or imperial screws. We're using imperial, so for the X-axis it's 16 threads per inch, so that's what I've got plugged in. 200 steps per revolution for the stepper motor. Some of them have a go up to 400, so you can adjust that accordingly, but generally speaking you're going to be at 200. And that will output a value here of the motor steps per unit. Since this is an imperial machine, that's steps per inch. Okay. Next we have a screen here to describe the X-axis itself. This would be the movement of the axis. The positive travel for the carriage is 6.5 inches on Mark's machine, and somewhere around 1.5 inches of negative travel. I've set the home final position at 6.25 inches to get it off the home switch after it finds home, and then the home switch is located all the way at the end of the axis at 6.5 inches. The next values describe how the home sequences work. First thing is the home search velocity at 3 inches a minute. That's when it's going to find the switch for the first time around. After it trips the home switch, it'll back off and come back into it to do a more precise calculation, to do a more precise location of it, in case you have over travel or coasting. So we specify that at 1 inch per minute. And then down here you can do home sequence. You can specify which axis is going to home first. In this case, x-axis is going to home first, and then it's going to be the Z. Z motor driver information is all the same. The only difference here is the lead screw threads per inch is 13 instead of 16. And I want to point out down here that we have a maximum velocity and a maximum acceleration for both axes. You can specify independently. Max velocity for the Z is 70 inches per minute, and the acceleration I set at 20 inches a second squared. You just have to play around with those values and find what works for your machine. On the Z-axis configuration, we have 24 inches of travel between the headstock, and I've got the final home position set at 2 inches. And just like the other axis, it's 3 and 1 for the home search velocity and the latch velocity, and its home sequence is set to 1. That is pretty much all there is to configuring it from default. You can go in on the command line and do additional tweaks using an editor, and we may need to do that later on after we get the machine installed, or get the controller and the stepper motors installed. We'll just have to see. Next thing I want to show you all is how he's going to upload his files to the controller. He will just log into a browser on his laptop or his desktop, whatever he's using to do his CAD CAM, and we'll go to Winky's CNC.local in the web browser, and it will bring up this interface. This is a CNC File Manager. This is a package that was written by Knox Makers for their laser cutter. By default, it's a multi-user interface, but it's been stripped down to be only one user for Mark's applications. And basically you just click the upload button here and upload your G-code file, and then LinuxCNC, it will pop up in the LinuxCNC folder, and you can select that and run it from there. I thought this would be easier for him to use than trying to use thumb drives back and forth or set up networking on his computer to network with the controller. All in all, that's pretty much it. I'd like to say that Linux and LinuxCNC can be intimidating, but it's really not that bad. It's very user-friendly. LinuxCNC has a large following. We have an IRC channel, a forum, and a mailing list. Very responsive. The gentleman who designed and builds and sells the MESA cards is a member of the community and is accessible on all 3 of the communication platforms, so you have direct access to him to help you with your configuration needs if something's strange or different about your machine, or you're just having general problems. So I'd encourage you all to take a look at LinuxCNC when you get a chance. That's it for this. Hey everyone, welcome back. So today, visiting the shop, we have Mark with Winky's Workshop, and I'm giving him a tour of the makerspace down here and the machining area. And we're just spending the day. He came down and picked up his CNC controller for his lathe and shot a little video of that. And hopefully he'll get back to his home shop and get it installed and have some fun with that.
I'm looking forward to it. It's really amazing. Billy did some good work on it. It's really impressive work.
Well, thank you. If you have any problems, let me know. You got my number.
Yeah, I'll probably have some problems. G-code and CAM. I know a little CAD, but G-code and CAM are all new to me, and I'm looking forward to it, though.
Yeah, it's a whole new world out there.
Yeah, it's going to be neat.
Well, folks, I've been giving him a tour of the shop here, and we're going to do a little bit more. I'm going to take him down to the blacksmith building and show him that, and I think we're going to go out to eat after that. Nice having him here, and we'll talk at you later.
It's a great place.
Thank you.
Yeah, this is a really nice setup. Thanks for the tour.
You're welcome. Oh, and by the way, don't forget to click the like, subscribe, and ring the bell.